Hello, focused learners, and welcome back to this explainer. I am so incredibly pumped you're here today because we are taking a deep, strategic dive into the absolute most critical elements of the Cambridge IGCSE Additional Mathematics syllabus, specifically the 0606 course. Today, we're not just looking at numbers on a page, we are acting like master photographers. Think about it. A great photographer doesn't just point and shoot. They find the perfect angle, they frame their subject to highlight the absolute key evidence. And that is exactly what we are going to do with your math answers today. We are decoding the exact strategies needed to conquer logarithmic and exponential functions. We aren't just skimming through basic textbook theories that you already know. No, we are looking straight into the examiner's playbook to understand exactly how they award marks, what angles they're looking for, and how you can frame your answers to guarantee maximum points. Let's get right into it. Look at this quote right here. Consider this golden insight straight from the examiners themselves. The difference between a B and an A star in additional mathematics often comes down to how well you understand logarithmic and exponential functions. I really want you to let that sink in for a second. Getting to grips with natural logarithms and the exponential function, it isn't just another casual box to check off on your revision list. It is literally the ultimate deciding factor for securing those top-tier grades. When you are sitting in that exam hall, staring down the barrel of a multi-part 0606 question, your ability to confidently manipulate e to the power of x, or intuitively understand the graph of ln x, is what will completely separate a pretty good paper from a truly outstanding A-star paper. This right here, this is the battleground where the top grades are won and lost. So we're going to make sure you're armed and ready. All right, here is our roadmap for this explainer. First, we'll cover the core principles. Second, we'll get into the technical methodology. Third, we are going to break down the deconstruct, solve, evaluate framework. And finally, we'll wrap up with the top examiner warnings. Let's jump in. Starting off with Section 1, Core Principles and Theoretical Foundations. Okay, I have a direct question for you, and I want you to really think about this honestly. Why do students find applying concepts to unfamiliar contexts so incredibly hard? You already know the basic rules of logarithms, right? You know what e to the power of x looks like on a standard graph. So why, when you turn the page and suddenly face a complex, unfamiliar word problem about continuous compound interest, or a weird radioactive decay scenario you've never seen before, does your mind just suddenly go completely blank? Well, let's picture two types of students. Let's call the first student Alex. Alex overloads his brain with raw mathematical facts. He memorizes every single formula, every single derivative, but there's absolutely no analytical framing. When the context changes, Alex freezes because he's just looking for a plug-and-play formula. Then you have Sam. Sam understands the math, but rushes through the setup, completely missing the specific command word requirements in the prompt. Both Alex and Sam end up with heavily marked up papers full of red pen, because Cambridge explicitly designs these questions to test if you've simply memorized a rigid procedure, or if you actually possess a connected conceptual understanding. The exam board wants to know if you can adapt. Rote memorization will only get you a passing grade. The A-star requires you to see the underlying matrix of the problem. And that perfectly illustrates the massive contrast between superficial breadth and analytical depth. The Cambridge Assessment Framework heavily prioritizes analytical depth. The examiners don't just want you to vaguely know a wide variety of formulas. That's superficial. They want you to demonstrate logical, structured reasoning. Think about how top students structure their answers. They implicitly use a framework, almost like they are making a structured argument. They make their mathematical point, they provide evidence through their working, they explain the transformation, and they link it back to the question. For example, they don't just know that the natural log of x and e to the power of x are inverse functions. They know exactly how their asymptotes behave, how the domain of one becomes the range of the other, and they recognize exactly how a visual transformation on one affects the algebraic equation of the other. Deep, connected understanding is the key that unlocks those unfamiliar contexts. It's about framing the math correctly. Moving on to Section 2, Technical Methodology. But before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Now, let's talk about the absolute goldmine of Cambridge exams, the method mark strategy. This is where we start turning those red pen marks into green check marks. Marks in additional mathematics are awarded for demonstrating the logical process, your systematic analysis, and your evidence-based reasoning. They are not just given for the final mathematical answer. Let me say that again. The final answer is only a tiny piece of the puzzle. Did you apply the power rule correctly? Did you show the specific step where you decided to change the base of the logarithm? Did you explicitly write down the intermediate equation before isolating x? The examiners are looking at your working as a piece of evidence. Even if you make a tiny, silly arithmetic error right at the very end, maybe you dropped a negative sign, a beautifully framed, sound procedural journey captures the vast majority of the marks. This is your mathematics success blueprint. You have to show your work, every single step. Don't do the heavy lifting in your head. Put it on the paper so the examiner can actually see your brilliance. And securing those method marks relies heavily on strict presentation conventions. Data interpretation from complex texts and tables relies entirely on these exact rules. Proper headings, correct terminology, appropriate formats, and crystal clear annotations. Imagine you are drawing a graph of e to the power of x. You must clearly annotate that y-intercept at coordinates 0, 1. If it's a shifted graph, you need to draw and label the new asymptote with its exact equation, like y equals 2. If you're interpreting raw data from a table to form a logarithmic equation, you must use the correct base notation. Don't just write log if it requires the natural log, ln. Writing log instead of ln or failing to label an axis might seem like a small oversight to you, but to the examiner, it's a failure to communicate mathematically. Failing to follow these strict conventions is basically taking easy, guaranteed marks and just handing them right back to the examiner. Don't do it. Frame your answer perfectly. Welcome to Section 3, the Deconstruct, Solve, Evaluate framework. All right, get ready, because we are turning this into an interactive workshop. Imagine I just flashed a massively complex mathematics data source on the screen right now. A terrifying, unfamiliar word problem about an exponential cooling model. You have a 60-second mental timer. What do? You use this sequence. Treat this as your absolute essential mental checklist during the exam. Step 1. Identify the given information. Scan the text, extract the relevant data right out of the paragraph. What is the initial temperature? What is the rate constant? Write those variables down immediately. Step 2. Break the problem into logical steps. Which analytical framework are you selecting? If the unknown variable is in the exponent, you know you are going to be taking the natural log of both sides. Plan that out. Step 3. Solve systematically. This is where you execute with clear notation and correct terminology step by step. Step 4. Check for reasonableness. Listen to me, this is huge. This is where you find the flaw in your own work. If you solve an equation and get x equals a -5, but that x represents time in an exponential growth model, or it's the internal argument of a logarithm, you should immediately recognize that something is wrong. Time cannot be negative here. A logarithmic argument must be greater than 0. Step 5. Make justified recommendations or conclusions based on your findings. Link it back to the original question. And that brings us to another layer of higher-order assessment, comparative analysis. Sometimes you'll be asked to evaluate alternatives or compare two different mathematical approaches. Imagine you're reading a flawed sample paragraph from a student comparing two logarithmic models. The audience challenge here is finding the flaw. What usually loses marks? It's when students just list facts without connecting them. When doing this, examiners explicitly state that you must identify similarities and differences. You need to use comparative connectives, words like whereas, conversely, in contrast, to show your logical flow. And crucially, you must support each comparison with concrete mathematical evidence before drawing conclusions. It's about showing the examiner that you understand the big picture of how these mathematical tools relate to one another. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications to never miss our weekly exam strategy sessions. Moving into our final phase, Section 4, Top Examiner Warnings. Straight from the principal examiner reports, here are the top 3 errors that consistently rob students of that A-star grade. I want you to imagine a 30-second speed writing challenge where you have to write one perfect paragraph. If you make these mistakes, you fail the challenge. Number 1, forgetting proper format. Just as we discussed earlier, sloppy notation with your ln or e terms costs 2 points. If your e looks like a c or your exponent drops down and looks like a multiplier, you lose the method mark. Number 2, failing to check presentation. If the examiner cannot clearly read your logical steps, or if your graph annotations look like scribbles, they cannot award you anything. They aren't going to guess what you meant. Number 3, providing generic answers. Now let's look a bit closer at this last one because it is incredibly common and entirely preventable. The examiner reports literally call this out as the classic mistake, providing generic answers that are not specific to the question context. If you are given a complex word problem about exponential population growth of a bacteria culture, your final answer and your explanation shouldn't just talk abstractly about the variable x or y increases. No, you must link every calculation and every single point back to the specific scenario provided. State what your mathematical finding actually means for that bacteria population. Therefore, the population of the bacteria culture reaches 5,000 at exactly 4.2 hours. This proves you have that deep, connected conceptual understanding we talked about at the very beginning of this explainer. You've decoded the command word, you've applied the framework, and you've managed your time perfectly. Look, I know exams are intense, high-pressure environments, and it is so easy to forget these rules when the clock is ticking down. So here is a quick memory hack. Create a mnemonic using the first letters of the key terms to lock in the required format and terminology. For example, for our core framework, deconstruct, solve, evaluate. Think of the phrase, don't stress exams. D for deconstruct the prompt, S for solve systematically, E for evaluate the context. Having a quick mental trigger like that will help you instantly snap back into those strict procedural conventions when you start to feel the time pressure. It's a lifesaver. So I leave you with this final, critical question. Next time you face a totally unfamiliar exponential or logarithmic problem in paper 0606, will you panic or will you deconstruct, solve, and evaluate? You now have the exact playbook the examiners use. You know that the process matters just as much as the final answer, you know the strict presentation conventions to follow, and you know exactly which common traps to avoid. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Thank you for joining me on this explainer and keep pushing for that A star.